Hello guys, my name is Engineer Holiday. We want to solve this mathematical induction. We want to prove it. Combination question with mathematical induction. It says using mathematical induction, prove that n combination r minus 1 plus n combination r equal to n plus 1 combination r for all positive integers n greater than or equal to r. Now, n combination r is equal to n factorial over n minus r factorial, which is the same thing as what? As what? That means r factorial, which is same thing as what? Saying n into bracket n minus 1, n minus 2, dot, 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 then n minus, now, the last term for this particular word then is what? N minus r factorial. Now, but the question is, how do we get to this last term? For me to get to this last term, I have to get to n minus r plus 1 first, second to the last, before I will now get to n minus r factorial all over r, n minus r factorial and r factorial, so that this can actually eliminate this. So what we are going to have is n into bracket what? N minus 1 into bracket n minus 2, n minus r plus 1 all over what? R factorial. So this one is a what? Another way of writing what? N combination r. Now this, we will need this now to solve. First of all, we are going to what is step 1. What is step 1? Is show that what? It is what? True for what? N equal to 1. And don't forget our n, it is obvious that r, it was what? Cannot be what? Be greater than n. But r cannot be greater than n. So if r cannot be greater than n, therefore let's take our r to be equal to what? 1 also. If you remember in the question, they told us that n is greater or equal to. So we take what? R to be 1. Therefore, if you write it now, we should do the first test. So I would have what? 1 combination what? 1 minus 1 plus what? 1 combination what? 1 is equals to what? 1 plus 1 combination 1. What will give us is 1 combination 0 plus 1 combination 1, 2 combination 1. So if you check this one will give you 1. If you do this one will give you 1. And if you do this one will give you 2. It means that it is what? 2 equal to 2. That means it is what? Correct. Now, number 2 is that what? Step 2 now. Step 2 is to what? Assume that it is what? True for n equal to what? K. So what we want to do now, we put k anywhere we see n, we assume based on the fact that it's true for what? We have shown that it's true for n equal to what? To 1 plus what? K, that's it. K combination r equal to what? K plus 1 combination r. So we now go with the proof now. Now this last step, which is to end this particular question, is what? To show that it is true for what? N equal to what? K plus 1. And which I want to do now lastly. So anywhere we see n, put k plus 1 there. I would have k plus 1 combination r minus 1 plus what? K plus 1 combination r equals to what? K plus 1 plus 1 is k plus 2 combination r. So we want to work with this one to see whether it will give us that last one. We want to show that will give us this. Now what we're going to do now is that this one now is same thing as what? K plus 1 into bracket k, like a k minus 2, dot, dot, dot. The last term will now be what? Because it's supposed to be over divided by this minus this what? K minus r, k minus r plus 2 factorial, and r minus 1 factorial. Don't forget this minus this, just like you have what n minus r. So this is n minus r. So what is the term before this one? The term before this k minus r plus 2 should be what? K minus r plus 3. Addition of 1 to this one. Don't forget that addition of 1 to n minus r will give us plus 1 here. So k plus what? Minus r plus 3 plus. Similarly, we are going to do the same thing. Although this one will cancel, don't forget that the last term is what? What is the last term? K minus r plus 2 factorial. Now, when you begin to reduce it, it will reduce to the point of this one. Before you get to this one, the third, second to the last term is this one. So this one will cancel this. So plus, then this one will now also be what? K plus 1 into bracket k into bracket k minus 1. What do we have now? Dot dot dot. And what is the last term for this one? K what? K minus r plus 1. That is factorial. Then r minus. That means this minus this will give us this. Then r factorial. Then if this one is the last term, the second to the last term will now be what? K minus r plus 2. Which is what? Which is k minus r plus 1 will now cancel out. Factorial will come. So we are left with that one. So we now factorize. Let's factorize now. So if you factorize now, what we have left? Don't forget that r factorial can be written as what? R minus 1 factorial. R into bracket. R minus 1 factorial. So what is common now on both sides is, first of all, r minus 1 factorial is common. Then what is common again? I think this one we will get to k minus r plus 3 before this one. If you remove 1 from this one, you are going to have this. So that means this one is inside this one. Normally, if I should write the second to the touch to the last term, should be what? K minus r plus 3. That means we should be here before this. So that means this one is part of this particular factorial. So we have k plus 1. K into my k minus 2 into bracket what? Sorry. Then dot dot dot. Then k minus r plus 3. That's what we are going to have as factors there. Open bracket. If you remove everything, we have removed everything. What remains here is 1. If you what remove other ones, what we have here is what? K minus r plus 2 all over r. That's what we are going to have. So to finalize it, to finalize the solution, what we are going to do is to what? Finalize the solution. What we are going to do now is to open the bracket, find the LCM of that r. So LCM of this 1 and r. What is the LCM? R. R divided by 1 is what? R. R times 1 is what? R minus k, two brackets here please. K, now r divided by r is what? 1. 1 multiplied by everything here will give us what? K minus r plus 2. This is what we want to have now. Then we are going to have what? K plus 1 into bracket what? K minus 2. K, let me stop there. Dot dot dot, we have k minus r plus 3 all over r minus 1 factorial. So what we are going to have that this one will cancel this one because it will not be plus. You understand? That will cancel that. Okay, this is plus. Sorry. Plus. Because it's plus that we have here. So plus. So r divided by 1 is r plus r divided by r is 1. But r divided by 1 is r. So that's what I have here. Now left with what? K minus r plus 2. So this r will cancel out this r. Now we are going to have the k plus 2. So the k plus 2 can be at the beginning as k plus 2. Before k plus 1, before k, for k minus 2. And so that equal to k minus r plus 3 all over what? Then this r will come before then r minus 1 factorial. So that this what we have here is actually what? R factorial. So what we have here is what more or less like what? R factorial. So what we have here is like what? K plus what? 2 factorial. And then we now have it as what? K plus what? Minus what? R plus what? 4 or plus 2 factorial. That's what we have there. Because the last one should be what? What? 2 plus 2. So this one now is more or less like K plus 1 combination or R that we are going to have. K plus 2. Because this is K plus 2 now. That's K plus 2. You understand? This one was derived from here, K plus 2 factorial. Then the last one, after this term, what the last term should be what? K minus R plus 2 factorial. So therefore, what we are going to have now is, if you subtract this minus this is what I want to have. Then if you start with this one is here, so we start with 2 factorial, then R factorial, which is correct. So we have proved that this particular one, this plus this give us what? This plus this will give us this. That is the proof now. So we can now conclude. Therefore, it is what? Proved, or it is what? Valid by what? Mathematical induction. By mathematical what? Induction. Thank you. I believe you enjoyed the class. So make sure you go through it and revise through the question again. We have proved all this one by mathematical induction using combination proof. Using what call it? Mathematical induction. We are able to prove the combination that it is valid. That when you say K combination R minus 1 plus K combination R give us K plus 1 combination R. Thank you. God bless you.